So, good day, everyone. So, I'm here to complete the electronic factors that affect a chemical reaction. In the previous video, we have done inductive effects, mesomeric effect, electromeric effect, resonance effect, conjugate effect, hyperconjugation effect. So, the last aspect is steric effect. Steric effect. Steric, steric effect. Good. So if I'm talking of steric effect, what is steric effect? Excuse me. The steric effect is an effect that concern with the bulkiness of alkyl group around a reactive or a reaction carbon center. The bulkiness of what of alkyl group around a reaction center or around a reaction carbon center in a compound, we call it what? Steric effect. And the steric effect may increase the reactivity of the reaction and can also lead to the what? Decrease the reactivity of what? Of the compound. So when the steric effect is increased the reactivity of the compound, we call it what? Steric acceleration. But when the steric effect is what? Decrease the reactivity of the compound, we call it what? Steric hindrance. So let me start from definition here. Steric effect. This occur when the bulkiness of a key group, bulkiness of a keywords, a key group around a reactive center, around a reactive what? Center of an organic compound. Of organic what? Compound. Like I said, the bulkiness compound. I said the bulky group, which is a keywords, a key group, may lead to increase or decrease in reactivity. Reactivity of the compound. Organic what? What? Compound. So this occurs when the bulkiness of alkyl group around a reactive center of what? Of organic compound, and the bulkiness of alkyl group may lead to the what? The increase in what? May lead to increase in may lead to increase in increase or decrease in the reactivity of what? Reaction. And I said when is increase, we call it what? Steric acceleration. When it's decrease, we call it what? Steric hindrance. Take for instance now, let me use this side. Take for instance, if we have organic compound of this COO, here we have alkyl group, we have alkyl group, we have alkyl group. COOH, yes. Look at this now. This is carboxylic acid. Abi? And we know that is what we have how many alkyl group here? 3. So the bulkiness of this what alkyl group will affect this carboxylic what? Acid. And the affection may be what? The effect of this bulkiness, it may be increase the reactivity of this compound or decrease of reactivity of this compound. Compare to if you have what? A carbon with OH, R, R, R. Look at two of them. They are different though. This compound is what? Carboxylic. Cylic what? Acid. This one is alkyl what? Alkanol. So if you are talking about bulkiness, that is what? You have bulkiness of alkyl group here, and this reaction catalytic carbon, we have bulkiness of what? Of alkyl group here too. So the presence of this steric alkyl group here in this reaction center carbon of alkanol here is called steric effect. And the bulkiness of what? This steric alkyl group we have here is also called what? Steric what? Effect. And note that is what? The alkyl group, they are electron releasing group. Electron donating what? Donating group. So we can put this arrow here. What is the meaning of that arrow? Under inductive effect, there are positive inductive effects. So they release electron to the what? To the carbon atom. So this is what we call what? The inductive what? The steric effect. So the next thing that we like to explain now is how the bulkiness of what? Of alkyl group affect reaction. I said what? Some reaction, the bulkiness may lead to decrease in the reactivity of organic compound, but at times it may lead to the what? The increase in this reactivity of what? Organic what? Organic compound. And before I will move to that, this steric effect is also a phenomenon that explains the amphoteric behavior of what? Of acid. Amphoteric what? Behavior of what? Of acid. Know that what? We all know that acid are what? Amphoteric. Amphoteric of behavior behavior of alkyl what? Alkanol. So if you want to explain what the amphoteric behavior of alkanol, you know the meaning of that? The alkanol behave like what? Like base, as well as what? As acid. The effect of what? Of steric what? Effect is one that they can use to what? To explain why is it that what the alkanol behave like acid and as well as what? As base. Take for instance for that one, what is the meaning of amphoteric? Any substance alkanol can behave like acid, can also behave like what? Like a base. You know, from Arrhenius Arrhenius concept of acid. Any substance that ionize or that produce hydrogen ion in water is what is an acid. But any substance that is produced what? OH in what? In water is a base. Abi, according to the what? Are you what? Arrhenius. But look at alkanol family. We all know that what the alkanol family of organic compound, this is their general molecular formula, R was CO. Abi? Yes. And this what? The OROH. This OH is the functional group. But if we have what? Alkanol in this form, we have ROH. Abi? And we also have ROH. Good. The bond cleavage that occur between what? If this ROH, if this H is ionized from this compound to form acoside ion, this alkanol behave like what? Acid. But if what? OH is the one that is what? Ionized from this compound, this alkanol behave like a what? A base. Take it now. Assume the bond cleavage we have here is what? Is the hydrogen that is what? We remove here. It's ionized there. When hydrogen is what? Is ionized here, we will have what? RO plus hydrogen plus. In this reaction, the alkanol here behave like what? Acid. It's behave like what? Acid. But if it is what? The OH, the RO cleavage is what that is will break. If it is bond between the Aki and O is what will break, you know, we have it in this form, Aki. We have carbon what? R plus OH minus. In this case now, the what? Alkanol here is a what? Is a base. Is a what? Is a base. But I said what? The factor that determine whether what? Alkanol will produce hydrogen ion, which is acidic, or the alkanol will produce what? OH, which is base property, is the what? Is the bulkiness of what? Of alkyl group. Will determine the ion, the one that is what? The bond that will break. It will determine the what? The bulkiness of what? Of alkyl group. Are we? Good. So, if I go to the what? The types of steric effect now, you will understand this very well. So, or let me put it this way. Okay, yes. There are types of steric what? Effect. That is type of steric effect. There are two types of steric effect. The first one, there are types of what? Of steric effect. Types of steric the what? Effect. There are two types of steric effects. The first one we have what we call was steric acceleration. Steric what? Acceleration. And the second one we have steric what? Hydrants. So let's take it one after the other. What is the first one? Steric as a what? Acceleration. What is steric acceleration? In steric acceleration, so what? Steric acceleration. The steric acceleration increase the reactivity of organic what? Organic compound. This increase in what? Increase the reactivity of what? Organic compound. So when the steric effect increase the what? Steric acceleration effect. So when the steric effect increase the what? The reactivity of what? Of organic compound, we call it what? We will call it steric what? Steric as a what? Acceleration. Example of steric acceleration is, look at this compound now. If we have what? R, H, R, here. Look at this now. Assume I will now put what? OH here. The presence of this three alkyl group here on this reactive center carbon atom will favor the basicity of what? Of this compound. Will favor the what? The basicity of what? Of this compound. That is the alkanol, the reactive center of alkanol that possess the bulkiness of what? Of alkyl group. It's the effect of the bulkiness of alkyl group there is what? It will favor the what? The basicity of what? Of this compound. As a result of that, it will make this compound to ionize faster, to release what? The OH in him what? Faster. You will now have what? R plus OH minus. So, and this reaction will be what? It will fast. What make this reaction faster? Or what make what? This alkanol to release what? OH, not to release what? Hydrogen. Ion. Because of the what? Of the bulkiness of what? Of this alkyl group in this reactive center. And it's what? It's favor the basicity of what? Of this alkanol. Compared to if you have what? An alkanol of CH, H, H, O what? OH. Can you see this one now? Compared to what? Alkanol of what? Of this. So this one is an alkanol without what? Without alkyl what? Alkyl group. So in this reaction, the presence of what? Of bulkiness alkyl group is what? It favor the basicity of what? Of this reaction. Then this alkanol will now what? Release what? It will release hydroxy ion. But if you have a alkanol compound without what? This alkyl group, if you want to ionize, it will be what? Release hydrogen what? Ion. Which is what? Acidic. So this is what? Steric what? As a what? Acceleration. So the next one is what? Steric hydrous. What the second one? Steric what? Steric hydrous effect. The steric hydrous effect This is an effect that decrease. This effect do what? Decrease the reactivity of organic what? Compound. Take for instance for this one, if we have what? A compound of alkyl group, alkyl, we have carboxylic acid H here. Yes. As we all know that what? This carboxylic acid is an acid. And the unique feature of acid is what? To release hydrogen ion. Abi? Like what? Alkanol, they are base. Their unique feature is what? To release what? OH. But when the alkanol now have what? The reactive center of what? Of alkanol have bulkiness of alkyl group, it will now make it easier for him to what? To release the what? The OH in him. But this one, his own feature is what? To release hydrogen ion. Going to the ionium. So ionize the hydrogen ion in it. But the presence of what? The presence of this alkyl group here will affect the what? The ionization. So it will either ionize to what? R, R, C, O minus, no, C what? OO minus plus hydrogen this. It will ionize, oh, but what happened to what? To the reaction? The reaction will be what? Will be slow. What did I say? The reaction will be what? Will be slow. What make this the reaction and of what? Of this ionization of what? Of carboxylic acid to be slow because of the what? Of the bulkiness of what? This it should find it difficult to release this hydrogen ion. What make it difficult? Because of what? This bulkiness of what? Of this alkyl group in it. Take another case and another example. If I have what? CH, H, H with COOH like this. If this one want to ionize, it will give us what? H, H, COO minus plus hydrogen. This reaction will be what? Will be faster. What make this one faster than this? Because there is no what? Alkyl group here. Am I communicating? So this example we have on top here is a good example of what? Of steric what? Of steric hindrance. It will inhibit the ionization of what? Of carboxylic acid. So that is what? This another example of steric what? Hindrance. Let me put it, let me give one more example on it. If you have a compound, yes, look at this compound. We have what? Yes, aniline. Look at aniline, nitrogen H, H, benzene ring. Do you know that is what? Here we have one lone pair of electron. And it's very easy for this what? Aniline to transfer this bond electron to this side, the resonance. And if you transfer this to this side, this one will come to this side. Abi? So if it is happen like that, you know that what? We have what? We have the structure will become NH. This one is loose, it's Abi. We have plus here. This place will be double bond. It has shifted to it. Then the benzene ring is this. The benzene what? Benzene ring. Abi? So this double bond remain here. This one remain here. Abi now. So the one that is come here, it will become what? Minus. Abi? And this thing can also continue like this by taking this one back here, and this pi bond will also come here. If you remember, in what? From the resonance, Abi? But look at this second case here, please. As though we have aniline, yes, NN dimethyl aniline. If I put what? CH3 here, let me move it. We have N, here we have CH3, here we have CH3, and here we have what? The what? Benzene. Can you see it here? We have benzene. This is what? And what? Aniline is what? Benzene mine. Abi now? But if I replace these two hydrogen now with methyl, Abi, with what? Methyl, you know, this one, I remove this hydrogen, I put what? Methyl there. Abi? So this lone pair of electron we have here, it will find it difficult to shift to this side. This one can never what? Possible. Why? Because of the what? Of the bulkiness of what? Of these two alkyl group here. It will affect the shifting of this lone pair electron to the side. That is what? Steric hydrants. So, but here it can what? It can shift. Why? There is no bulkiness of alkyl group at what? The outer center here. So that is what? Another example of what? Of steric hydrants. Let me now give you to this logic question. See you. I will write it down and you help me to what? To answer it. Okay, I will use alkanon and alcohol. Look at this reaction. We have reaction of CH3, COOH plus CH3, CH2OH. Do you know that's what? This is acid, this is the base. It will give us what? Ester. Abi? And another reaction, I decide three here, Abi. I decide to change this to what? CH3 on top, CH3 at the back, CH3 at the back, COOH plus CH3, CH2OH. If you ask, the reaction of ethanoic acid and ethanol, it will give us what? Methyl ethanoate and what? And water. And what? 2,2-dimethyl propanoic acid and ethanol acid. If these two react together, they will now ask you which of the reaction will react faster. Which one is what will be react what slower? Which one will be faster? Which of the two reactions? Can you solve it? See, This reaction, this ethanoic acid, this is what ethanol. Have you know? The reaction between two of them here, do we have any buckiness of alkyl group here? No. Therefore, this reaction here will be what? Will be faster. This reaction here will be what? Will be faster. This reaction here is what? Faster. What makes it faster? Because there is what? No alkyl group on it, which will what? Reduce the formation of what? Of ester. Hello? So this one will be faster. And then what happened to this one? This one will be what? Slow. What makes this reaction slow? Due to the what? The presence, slow, due to what? Presence of bulkiness. Bulkiness of what? Of alkyl group in acid. What is acid here? Carboxylic acid. The bulkiness of alkyl group we have here, it will reduce the efficiency of ionization of what? Of this H. But here, there's nothing that will disturb the what? The H ion to what? To ionize. And nothing that, yes. Okay, but in another case, so in another case, if you are given, let me change it. If you are given a reaction of CH3 COOH, ethanoic acid, with CH3OH. Look at, and the other one is what? CH3 COOH plus CH3 CH2 and OH. Can you see this one now? This is ethanoic acid and ethanoic acid and ethanol. If the two react here, don't be surprised. The two here, they will what? They will slow. Where here they will what? Faster. The reaction here will be what? Will be faster. What makes this reaction faster? Because of the bulkiness of what? Of alkyl group here. In what? In acid. So the bulkiness of alkyl group in this acid, what? We make it easier for this ethanol 2,2-dimethyl ethanol to what? To produce the OH. The bulkiness of alkyl group here, we increase the basicity, favor the basicity of what? Of this alkanol to release the what? The OH. Here, it will release the OH, but it will fast, it will slow. But the price of what? CDC283 here, they will what? They will make it faster for this alkanol to release the OH in what? In it. So these are the what? The application of steric what? Effects. So we are done with what? All those effects. Done inductive effect, electromagnetic effect, mesomeric effect, resonance effect, conjugate effect, hyperconjugate effect, and the steric effect. So the next thing that we are going to move to is types of organic reaction.